started this discussion. We started this discussion with this question: how common is it for me to use exceptions? How common is it for me to expect them to occur? And how often should I be using try and catch? And the answer is all the time. You should encourage yourself to not to neglect statements like this and just say, well, I just hope that every time there will be correct input. Yeah, I know my program can crash because of this statement if something goes bad, but you know, it's not important. But the answer is no, no, it's important, and all realistic programs should be written. You know, how do you deal with this? You go read documentation for the statement. You find out what exceptions could be thrown from this statement, from this method, and you program accordingly. So you program with this expectation. And yes, you use try and catch method routinely, right? It's like your other version of if else. So if you know there is a possibility of exception taking place, then you use try and catch. If you're just dealing with your own logic of things, you just do if else. So you verify conditions, and based on the outcome of this condition, you just build your own logic, right? But exceptions are in a way more powerful because they're taking advantage of the stack frame, in general program stack, because they're propagated through the stack. And they're very similar to return mechanism. Just as we can return values from methods, exceptions are also referenced somewhere on the stack, and they're propagated back to the caller, and so the catch statements have a chance to connect themselves with existing exception objects, and then you know, continue on using them and not letting the program to crash. So in some way, it's similar to if else, but in reality, under the hood, exceptions are based on the stack of calls, and there is this technical term of exception propagation through the stack. Perhaps to say another, give you another demonstration on this, is that, let me just another illustration. So the main program right here, you know, starts, the main method starts execution. It has its own code right here, and this code has access to local variables. All right, then it makes a method call to another method. That method in its own turn makes a call to another method, right? So we'll call this method foo, right here, and then there's method bar, another method that is being called. And suppose that this method bar, generates an exception somehow, right? So here you go, an exception object is constructed. Okay, exception object is constructed. There's some sort of an exception object is manufactured, and now someone has to, we know that execution within bar is terminated right there, because we know that's the behavior of exception. As soon as exception takes place, the normal flow of events stops. Supposedly, that bar doesn't do anything at all to deal with this exception. It just like throws an exception and doesn't do anything. Then, so this will be gone, right? This will be gone, but not completely. The stack still keeps track of this exception object still. It's called exception propagation. Then foo decides not to do anything about this exception. Well, guess what? This stack frame and foo will also be terminated just like that. And then the stack, the program stack still keeps track of this. It's called exception propagation once again. And then finally, main method may decide to have a catch statement right here in its code, and it will be reconnected with this exception, and it can then say, oh no, we no longer want to collapse because we're about to, terminate the execution entirely, and now we want to deal with it. And so the catch statement eventually takes place. So exceptions could fall through multiple method calls. They all can collapse and restore stack as if there was a return taking place. You truly return from all these methods. Everything unrolls, and we're may end up in a place where the catch statement does its work and catches it. If it doesn't work, then main is gone. It will also unroll, and we will be terminated. And the default Java virtual machine exception handler will display some information, and it'll be the end of our program. All right? So this is exception propagation. Okay. Any questions about this? So that's why, by the way, because we have the situation, that's why when originally this exception object was manufactured, there was this, there was this information about the stack, and the stack was still there, right, at that point. So that's why Java Virtual Machine knows how to capture all this information. So then it captures it so you don't lose track of what happened and where, right? What happened tells you the type of exception and other information that it captures, but also it prints the location where the bad thing took place. So it does keep track of that. All right, so try and catch statement, some information about that. Catch block generally provides the handler for the exception. So you can import this. We have it in our sample here, input mismatch exception, something that we already did here. Again, there's this attempt to discard incorrectly entered value. The fact that we already covered this topic, that there could be multiple catch blocks dealing with different types of exception. That's allowed. The finally block. The finally block always executes. Now there's this misconception about the finally block, which I'd like to cover in, well, actually, you know what? It'd be appropriate to start on Thursday with this topic, just to cover what, well, try and catch are obvious things. Try says, I'm expecting bad things to happen, but I don't want to crash, so I want to handle the situation. The catch block is exactly that. That's the handler, right? But the finally block has this tricky purpose, and also sometimes you can have multiple try and catch statements in one single method, and then we need to discuss and discover how finally block works, because there's some misconceptions about that as well. So that's that to be continued on Thursday. All right. Well, thank you guys, and I'll see you on Thursday. Wrapping up here.